All right, so I'm going to continue in our lesson about learning of the confidence intervals. Today we're going to do confidence intervals for values that have very small samples or values where the standard deviation is not the standard deviation is not known. So with this, we're going to use something called a t-distribution, and more than likely, when you do your project, you'll end up using a t-distribution for your project. So it's a new chart. It's not something we've used before. So a t-score is very, very much like a z-score, just uses a different chart. Okay, and I'm going to show you how to use a chart in class because I thought that's easier than doing it over the video. So it's very, very similar to a normal distribution. It's called a t-distribution. It's just, it allows a little bit more margin of error. So we're going to continue on. And in this, realize that we're looking these numbers up in a chart, but that we're going to look at the chart tomorrow in class. So I want you to look at this formula, and I want you to realize that there is hardly anything different. The only thing different here is the fact that it's a t-score instead of a z-score. And it talks about the degrees of freedom. That has to do with when we're looking up a number on a chart, and we'll do that again tomorrow. But this formula is exactly the same as the one you used yesterday. So here we go, example 1. It says, for a group of 10 men subjected to a stress situation, the mean number of heartbeats was 126, and the standard deviation was 4. Find the 95% confidence interval of the true mean. So I want you to realize 10 is a very small sample size. So if your sample is less than 30, you must use a t-distribution. The standard deviation is known, but the sample size is very small. Most of the time, this is our trigger. So if you have less than 30, you use a t-distribution. If you have more than 30, you will use a normal distribution. So we're going to use this formula, the x bar equals t of alpha over 2 times the standard deviation, divided by the square root of n, is less than mean, is less than the mean, the sample mean, times the t-score, times s over the square root of n. And again, same exact formula, not difficult. So 126 minus the t-score, which I will look up on the chart. You always have to look these up. There's no good ones for this. Times 4, which is our standard deviation, over the square root of n, which is 10. And then I do 126 plus 2.262. I messed up when I was writing this. I kept putting too many 2's. 2.262 times 4 over the square root of 10. Again, simple. Just make sure you're putting numbers in the calculator right. So 126 minus 2.861 is less than the mean, which is less than 126 plus 2.861. Again, keep in mind that your number should be between they should straddle 126. So if your number is outside of the range, like if this is more than 126, you should probably try something different. Make sure you calculate. Again, usually it's a calculator error. So here is a practice problem, and I realized that I put the practice problem up here and didn't tell you how to find the score. So you want to go look at the t-score on the answer before you actually do this. So the mean is 0.32, standard deviation is 0.08. Find the 95% confidence interval of the mean depth. Go ahead and look up the t-score and then try the problem. So, and in the t-score, I mean check the answer. So this case, this t-score was also 2.62. So because the mean was 10 again, or the sample size was 10. So again, we're just plugging numbers in. Our mean minus our t-score, standard deviation divided by the square root of the sample, mean plus the t-score, standard deviation divided by the square root of the sample. And that's what we get. Example 2. Now, this one uses the idea that we have, you're given a set of data. You will have this. You'll have data, and you have to find the mean and the standard deviation from your calculator. You have to have a graphing calculator. You can't do this without it. So, so that's the first step, is actually plugging it in the calculator. And I get the mean is 91.06, and the standard deviation, use the S, okay, is 38.37. Then I use my formula again, 91.06 minus 2.583. This is the number I looked up in my t-score chart. The standard deviation divided by the square root of my sample size, which is 17. I do the same thing on the other side, just plus this time. Okay? So, right. Again, we're getting to a point where we're trying to learn what does it mean when I take a sample. Is it real? Does it mean anything? Is it significant? So confidence intervals are the first step in that process. So if I plug this all into a calculator, I get 67 is less than the mean, which is less than 115.1. Again, these numbers must be around the actual mean that I found. If these numbers are both bigger or both smaller, I've done something wrong. Go try again. Here's your practice problem. Again, you're given numbers. Plug them in. Find the 99% confidence interval. I think in this one I actually wrote the score up here for you. Maybe not. Yeah, I did. Okay, so the t value for this one is 3.707. So in your calculator, put these numbers in, find the mean, find the standard deviation. This is your t-score, and give it a whirl and see what you come up with. Here's the practice answer. Okay, so my mean was 7,041.4, and my standard deviation was 1,610.3. I plugged them all in, and I get my actual mean is somewhere between 4,785 and 9,297. This is 99% confident that it's between these two values. That is a huge range, by the way. And that's it.